Hello students, Maurice here. In the previous lecture, we discussed the examples based on logical connectivities. Now, today we are going to see next example. Today we are going to see next example. Suppose if P and Q are true, and R and yes are false. Next example is what? If P and Q are true and R and yes are false, then find the truth value of the following statement, of the following compound statement. Statement what? P implies Q. Here join with R meet yes. Okay. Question what? If P and Q are true and R and S are false, then find the truth value of the following symbolic statement or compound statement. Statement what? P implies Q, join with R meet S. We have to find the truth value of that statement. Now, solution here. P and Q are true, therefore the truth value of P and Q is what? T. Similarly, R and S what? False, therefore truth value of R and S what? F. Therefore, P and Q its value will substitute here T, and R and S its value we substitute here F, and then we can just use the truth table for logical connectivities, and then we get the required truth value of that statement. Now, in solution what? In solution here P and Q are true. Therefore the truth value of P and Q is what? T. Similarly, also R and S are false. Therefore the truth value of R and S is F. हे काय केलं आपण? गिवन वरून लिहिलं. P and Q are true statement, therefore its truth value is T. Also R and S are false, therefore its truth value is F. Now, to verify or to find, next line what? To find the truth value of, कशाची truth value find out करायला लागेल. Next to find the truth value of P implies Q, join with R meet yes. Truth value find out करायला लागेल. Therefore directly consider this statement. Therefore next line, consider this statement. What? P implies Q, join with R meet yes. Now which is equivalent to or equal to? Here we know that the truth value of P and Q is T. Therefore next one here P implies T. This join with here we know that the truth value of R and S what? F. Therefore F meet with here F. Now which is equivalent to? In the conditional statement, if first substatement is true and second substatement is false, then conditional statement is false, otherwise it is true. Therefore in the T, therefore this statement is T, and there the join. And in conjunction, we know that in conjunction if both the substatements are true, then the conjunction is true, otherwise it is false. दोन सबस्टेटमेंट जर ट्रू असतील, टी असतील तरच कंजंक्शन टी येते, अदरवाइज इट इज फॉल्स. इथे काय फॉल्स, देअरफॉर हियर वी गेट इट इज फॉल्स. नाउ इन डिसजंक्शन, you know that in disjunction if both the substatements are false, then the disjunction is false, otherwise it is true here, otherwise therefore we write it as T. We get T. Therefore this what? It is the truth value of statements P implies Q joined with R with yes. This what? Truth value of that. Question what? Question काय होता? If P and Q are true and R and S are false, then find the truth value of the following statement. Statement कोणतं घेऊन होतं? P implies Q joined with R with yes. या स्टेटमेंटची ट्रूथ व्हॅल्यू फाइंड आउट करायची होती. Therefore in solution what? Here P and Q are true. Therefore the truth value of P and Q is T. Also R and S are false statements. Therefore the truth value of R and S is F. Now to find the truth, next line what? To find the truth value of that statement P implies Q joined with R and S. Therefore याची ट्रूथ व्हॅल्यू फाइंड आउट करायची होती. Therefore आपण कन्सिडर हे स्टेटमेंट केलं. काय Therefore consider P implies Q joined with R meet S. Now which is equivalent to or which is equal to, here we know that the truth value of P and Q is what? T. Therefore we write here T implies T joined with. Also it is given that the truth value of R and S what? False. Therefore we write here F. Now which is next line, which is equivalent to in conditional statement. We know that in conditional statement if first substatement is true and second substatement is false, then the conditional statement is false, otherwise it is true. Therefore the otherwise condition hai, therefore we can write its truth value is T. Here this symbol join. Then in conjunction we know that if both these substatements are true, if in conjunction both these substatements are true, then the conjunction is true, otherwise it is false. म्हणजे काय otherwise condition. Therefore here F. Now here T join with F. Now in disjunction, this symbol what? Disjunction. Now in disjunction we know that if both these substatements are false, then disjunction is false, otherwise it is true. Therefore this otherwise condition. Therefore this value is T, and this what? This is which is the required truth value of a statement P implies Q joined with R with S. Therefore next line guys, therefore the truth value of a statement P implies Q joined with R with S is T, which is our required answer. Now next example. Now let us take next example. Next example, if P statements denote he swim and Q statement denote water is warm. Then question what? If P denote he swims and Q denote water is warm, then give the verbal statement of the following symbolic statement First one is P if and only negation of Q, and second one is Q implies P. Question काय होता? If P is the statement that he swims and Q is the statement that water is warm, then give the verbal statement of the following symbolic statement. It means symbolic statement कोणतं देणार आहे? P if and only negation of Q, and second one is Q implies P. म्हणजेच काय? या सिम्बॉलिक फॉर्म, या सिम्बॉलिक फॉर्मवरून आपल्याला स्टेटमेंट वर्बल स्टेटमेंट तयार करायचं. ठीक आहे, म्हणजे व्हॅल्यू काय? पी ची व्हॅल्यू सबस्टिट्यूट करणार, क्यू ची व्हॅल्यू सबस्टिट्यूट करणार, इथं निगेशन ऑफ क्यू घ्यावा लागेल. देन वी नो दॅट दिस सिम्बॉल व्हॉट? इफ अँड ओनली. Therefore in solution what? In solution first what have P if and only if negation of Q. Statement काय होईल डायरेक्टली? If and only if negation of Q. P statement what? He swim. This what? If and only if here negation of Q means statement Q चा negation घेतला आहे. Negation of Q means negation of Q आहे water is warm, then its negation water is not warm. If and only water is not warm, which is the required verbal form of a given symbolic statement, that you call verbal form. म्हणजे काय केले? P if and only if negation of Q. हा सेंटेन्स फक्त तयार करावी. P काय होता? ही स्विम, This what if I had only just take the negation of q, what, water is warm, therefore negation of q what, water is not warm, which is the required verbal statement. Now next what, second q implies p, second statement what, q implies p. This what, if then म्हणजे काय होईल, q implies p statement काय होईल, if he swim, then water is warm, which is the required verbal statement of a given symbolic statement. Second what, q implies p, this symbol what, if then, therefore we write its conditional statement of that two statements. Conditional statement, this what, conditional statement of these two statements. It means if he swim then water is warm, which is the required verbal statement of a given symbolic statement. Now next point, now take our next point is quantifiers and quantified statements. First upon quantifiers. These are the two quantifiers that we call for all. These symbol denote for all and that symbol denote there exist, and these two symbols is called quantifiers. We use these two symbols to write a statement in mathematical form. There are two quantifiers. First one is for all, second one is there exist. This for all, there exist. Now we use these two symbols to convert a sentence in mathematical form. For example, suppose if XII, for example, for every x belongs to real number, such that x square is non-negative, x square is non-negative. Here this is statement or this any sentence, simple sentence. For every x belongs to real number such that x square is non-negative. Now we can write this sentence in mathematical form with the help of quantifier for all. For all x belongs to the real number such that x square is non-negative. X square is greater or equal to 0. It means non-negative. Greater or equal to 0 म्हणजे काय होते, non-negative. This sentence, we can write this sentence in mathematical form with the help of quantifier for all. For every x belongs to real number, it means for all x belongs to real number such that x square is non-negative. X square greater or equal to 0, it means x square is non-negative. Here we use the quantifier for all. The next another, if we take for x belongs to natural number, such that x plus 4 which is equal to 7, this is also a sentence. Now we can write this sentence with the help of quantifier there exist in mathematical form as, suppose this what x belongs to natural number such that x plus 4 equal to 7 means what, x असा नॅचरल नंबर आहे याचा की इक्वल टू 7 आला पाहिजे. म्हणजे काय, देअर इज ओनली वन नॅचरल नंबर 3 बिलॉंग्स टू नॅचरल नंबर. इफ यू पुट x इक्वल टू 3 देन दिस इक्वेशन सॅटिस्फाईड. 3 सोडून दुसरा कोणताही नॅचरल नंबर इथं सबस्टिट्यूट केला तर इक्वेशन सॅटिस्फाईड होत नाही. म्हणजेच काय, there are infinite natural number, among that only one natural number satisfies this. For that we use the symbol or we use the quantifier there exists x belongs to the natural number such that x plus 4 which is equal to 7. This is what mathematical form we use here, the quantifier there exists. It means there are only two quantifiers. First one is for all for all. First one is for all and second one is there exist. These are only two quantifiers in mathematics. Now next definition is quantified statement. Next definition is quantified statement. Definition काय होते बघा. Next one is quantified statement. An open sentence with quantifiers. An open sentence with quantifiers becomes a statement. And that statement is called quantified statement. That statement is called quantified statement. Definition काय होती. An open sentence with quantifiers becomes a statement and that statement is called quantified statement. आपल्याला माहिती आहे ओपन सेंटेन्स स्टेटमेंट नसतं. ओपन सेंटेन्स इज नॉट अ स्टेटमेंट बट ओपन सेंटेन्स विथ quantifiers for all and there exist becomes a statement and that statement is called quantified statements. For example, if x plus 4 which is equal to 7, here I take x belongs to the natural number. X belongs to the natural number. X belongs to the natural number. It is an open sentence. This open sentence it is not a statement. हे स्टेटमेंट होत नाही. It is only open sentence. But quantified statement definition काय होते. An open sentence with quantifiers becomes a statement and then that statement is called quantified statement. Here this open sentence. Now if we use in that sentence, it is a open sentence. Now if we use in that sentence any among these two, any one quantifier, then it becomes a statement and that statement we will call quantified statement. Now here x plus 4 which is equal to 7 and x belongs to the natural number. It is sentence. Now x ची व्हॅल्यू कोणता नॅचरल नंबर घेतल्यानंतर सॅटिस्फाईड होईल. x इक्वल टू इफ वी टेक 3 then this given equation satisfied. For example 3 plus 4 which is equal to 7 then this equation satisfied. म्हणजे x इक्वल टू 3 असेल तरच हे सॅटिस्फाईड होतं. x plus 4 which is equal to 7. x plus 4 which is equal to 7. Therefore we can write this sentence in form x belongs to the natural number or there exists x belongs to natural number such that x plus 4 which is equal to 7. It becomes a statement and that statement we will call quantified statement. ठीक है. x belongs to natural number x plus 4 which is equal to 7. It is a simple open sentence. Now in that open sentence we use the quantifier there exists x belongs to natural number such that x plus 4 which is equal to 7. Then it becomes a statement and that statement is called quantified statement. That statement is called quantified statement. म्हणजे simple quantified statement definition काय होती. An open sentence with quantifiers becomes a statement and that statement is called quantified statements. Now take examples in exercise 1.5 or 1.6. Example or first example use first example if I take x square plus 3x minus 10 which is equal to 0. Question what? Use quantifiers to convert a following open sentence defined on a natural number. This sentence defined on natural number. ठीक है. Question what? Use quantifiers to convert the following open sentence defined on natural number into a true statement. म्हणजे काय हे जे ओपन सेंटेन्स आहे ते डिफाईन कशावरती केले सेट ऑफ नॅचरल नंबर वरती. हे ओपन सेंटेन्स आपल्याला कन्वर्ट करायचं आहे क्वांटिफाईड स्टेटमेंट और ट्रू स्टेटमेंट विथ हेल्प ऑफ क्वांटिफायर्स. सिंपल. नाव इट इज ओपन सेंटेन्स. सोल्युशन मध्ये काय होईल. हियर solution x square plus 3x. Here x square plus 3x minus 10 which is equal to 0 and this statement defined on the natural number n. It is open sentence we have to convert this sentence in true statement with the help of quantifiers. With the help of quantifiers, there are two quantifiers. We know that for all and there exist. For all and there exist. Now हे जे इक्वेशन आहे डिफाइन कशावरती केले, सेट ऑफ नॅचरल नंबरवरती. म्हणजे काय, एक्स असा नॅचरल नंबर घ्यायचा की तो इक्वेशन सॅटिस्फाईड केली पाहिजे. म्हणजे इक्वल टू 0. सपोज इफ वी टेक एक्स इक्वल टू 2, 2 इज नॅचरल नंबर. इफ वी टेक एक्स इक्वल टू 2, एक्स इक्वल टू 2 घेतली तर काय होईल, 2 स्क्वेअर प्लस 3 into 2 minus 10 which is equal to what, 6. Now 2 square what, 4 plus 3 into 2 what, 6 minus 10 which is equal to what, 0. 6 plus 4 10 minus 10 is 0. 0 equal to 0. म्हणजे काय, x equal to 2 satisfies this equation. x belongs to natural number. But 2 सोडून जर दुसरा कोणताही नॅचरल नंबर इथे घेतला तर काय होतं, इक्वेशन डज नॉट सॅटिस्फाईड. Means what? There are infinite natural numbers 1 to up to so on. Among that, only one natural number 2 satisfies this equation. Therefore, we can write there exists. Therefore, we can use here quantifier there exists. It means next line. Therefore, there exists. Or if you write therefore there exists x belongs to the natural number. There exists x belongs to the natural number such that x square minus 3x x square plus 3x minus 10 which is equal to 0. It is a true statement. 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 Why true? Reason खाली दो, since x equal to 2 belongs to the natural number satisfies this equation. X equal to 2 belongs to the natural number satisfies the equation. Satisfies the equation. On the equation satisfies the equation x square plus 3x minus 10 which is equal to 0. Which is the required answer of that question. Question क्या होता? Use quantifiers to convert the following open sentence defined on a natural number n into a true statement. ठीक आहे. Here solution मध्ये काय झालं, here given x square plus 3x minus 10 which is equal to 0 defined on natural number. Means natural number असे natural number घ्यायचे की इक्वेशन सॅटिस्फाईड केले पाहिजे. Means there exists only x belongs to natural number such that x square plus 3x minus 10 which is equal to 0. It is a true statement. हे ट्रू स्टेटमेंट झालं. Therefore since का ट्रू होते, since x equal to 2 हा नॅचरल नंबर हे इक्वेशन सॅटिस्फाईड करतो. ठीक आहे. विच इज रिक्वायर्ड आन्सर. काय करायचं